Welcome back, and just a wrap-up video. So we've been talking about determinants geometrically and kind of the idea that there's this scale factor between them, right? Or between the original image and its original figure and its image under the transformation. So the only question we have is what happens geometrically if the determinant is negative, right? We always say that the formula is the absolute value. So in this first one, if we look carefully, this was the one that we had from before, so this is going to take the vector 1, 0 to the vector 2, 1, and similarly, it's going to take the vector 0, 1 to the vector 1, 3. Okay, not 1/3, that's 1, 3. Okay, 1, 3. Okay, and so now if we reverse the rows, or reverse the columns, okay, this determinant ends up being -5, right? So then if we do this, what ends up happening is that the vector 1, 0 goes to now vector 1, 3. 1, 3. I want to write that as 1/3 for some reason. And the other vector, 0, 1, now goes to the vector 2, 1. So they effectively reversed. Okay, so a few more examples are going to be shown to you coming up here, and before I scroll, I want you to pause the video and see if you can predict the effect. So here we go. Here's the image, elephant, and then we want to know what happens to this. Okay, so again, pause the video, see if you can convince yourself what's going to happen. Was it that? So it sort of dilates by 2. Okay, that makes sense because the area is twice as large. Or the determinant is 2, so that means the area is twice as big. Okay, now -2. Okay, and in your mind, did this happen? Does it make sense? Okay. And now we have another one. What happens if the determinant is 1/2? What could happen? Could that happen? I think so. What if the determinant is -1/2? Again, pause the video. Okay, so it should sort of reverse its orientation and shrink in area. Okay, so determinants really is this idea of switching or reversing. Okay, and in this image, I want you, so again, the elephant is the original image. Is the determinant positive or negative? And then also, is it bigger than 1 or smaller than 1? This one, the determinant should be positive because it's roughly the same, or it's the same orientation, so the determinant should be positive. And the second one, what do you think? I think the determinant is negative. Okay, and this last one, is it positive or negative? This one should be negative as well. Okay, so just a few examples to let you see what happens if the determinant is negative. Now, as a final wrap up, 2 more things that we need to mention is if we have a certain type of linear transformation, we can maybe determine if the determinant is always going to be positive, negative, or 0. So scaling, is that going to be positive, negative, or 0? Generally, if we're scaling, it's going to be positive. Okay. If we're projecting, okay, the determinant's going to be 0. If we're reflecting, it could be negative, and in fact, if we were to think about our standard reflection matrix, I believe the determinant's going to be -1. Okay. If we think about a rotation, that's going to be a positive, and generally it's going to be +1 for the determinant if we think about our standard reflection matrix, and a shear is going to be positive as well. Okay. Another thing that goes hand in hand with this is we talk about orientation preserving and orientation reversing. Super critical idea here. Unfortunately, it just gets kind of thrown in at the end. But we talk about a transformation being orientation preserving if the determinant is positive. So that means it would look the same. It would be similar to the original image, just again scaled or rotated, something like that. But then the orientation is going to be reversed if the determinant is negative. Okay, so that kind of went in line with what we saw above in the previous images. Okay, and then just a final note, we don't really stress Cramer's rule, but it's a good thing to maybe dust the cobwebs off of. So just make sure to read over that in the section. Okay, so this video kind of wrapped everything up that we were talking about with the geometry related to determinants, and we'll get some more